For today's webinar, we'll be looking at using TPM thinking to enhance safety performance at your site. Our presenter today is Ross Kennedy. Ross is the president and founder of CTPM. He's recognised as Australia's leading authority on total productive maintenance and CTPM's operational excellence through the TPM and Lean methodology. So let's get started. We hope you enjoy today's webinar, and I'll now pass you over to Ross.
Good morning everyone, and welcome to our webinar today, using TPM to enhance safety performance at your site. Thank you for joining us, and hopefully you'll enjoy our discussion, and feel free to ask questions at any time as we progress. So what do we want to cover about TPM to enhance safety performance? I just want to touch briefly on what really is TPM, so we all come from a common understanding of what TPM is about. So there's some misunderstanding out there in the marketplace about TPM. Where does TPM fit into the safety improvement? What's required to achieve zero accidents? And what's the correlation between equipment performance and safety? And finally, what is the correlation between frustrations in the workplace and safety? So, just getting started, TPM came out of the Toyota production system, or was developed as the Toyota production system was developed. And as we all know, the Toyota production system, or as some people refer to it now, the Toyota way, is all about striving for perfection. So to achieve perfection, you need to create perfect processes with perfect equipment and develop highly skilled and disciplined people who can operate and maintain perfect processes and perfect equipment. So it's not just starting off with perfect processes or perfect equipment, it's the ability to ensure that they keep getting better or stay perfect. So it's about developing the people in the organization to continually look for improving your processes and equipment, and that's really what the Toyota way is all about. The interesting thing is, when you go back and look at the history of TPM, it was actually developed in the late 60s so they could get the Toyota production system to work. So Toyota actually developed it, and in doing so, set the foundations to allow the Toyota production system to work. In other words, they created the discipline and capability within their people through their TPM activities to allow them then to embrace what we now know as the Toyota production system. So TPM was originally known as total productive maintenance, with its main activity or pillar being autonomous maintenance, involving regular clean for inspections. Now, what happened is that a lot of people in the Western world sort of got a bit confused by this total productive maintenance. We heard about it in the late 80s, everyone had a go at it. However, a lot of people thought total productive maintenance was all about getting the operators to do maintenance work, especially when they start talking about autonomous maintenance by operators. In reality, what happens is the word maintenance has confused a lot of people, because in the Western world, maintenance means repairing, as opposed to in Japan, it tends to mean caring. For example, asking someone in Japan to describe someone washing their car, they would say they are doing maintenance on it. Whereas in the Western world, if we said describe someone doing maintenance on their car, it would be about repairing the car. So a lot of people in the West started trying to see TPM as a means of transferring tasks from maintenance people to operators, to get the operators to do some of the maintenance work. That way they figured they needed less maintenance people and they could save money, and this was all about cost reduction. Unfortunately, that didn't work. Maintenance people didn't like sharing their knowledge, operators didn't want to take on extra tasks. So after a while, a lot of TPM sort of thinking sort of got overtaken or overrun by Lean that came along in the mid-1990s, following the release of the book, The Machine That Changed the World. So I think it's worth going back and just really looking at TPM and having a close look at it from a correct perspective. So what really is TPM? It's about applying the quality concept of prevention at source to equipment. After the war, in the 50s and 60s, people like Dr. Deming and Dr. Duran, but mainly Dr. Deming, was over there talking about prevention at source for processes. In other words, finding your problems at the earliest possible time in your processes. And what they realized is that this concept of quality concept could be applied to equipment. And if they could find the small problems at the earliest possible time on the equipment, for example, fixing a damaged grease line rather than waiting for a bearing to fail, and here's a great example of, if we look at the arrows, where the grease lines have become disengaged from the connector that goes into the bearing on this rolling mill table. Now, as you can see on the floor, there's a lot of grease because the grease has been going up and down on the floor rather than into the bearing. Now, if you identify that at the earliest possible time, just after it happens, and you reconnect the grease line, there is probably no problem with the equipment, and the cost of doing that and the time is very, very minimal. If, however, you don't pick up on this problem, and in this case this was at the back side of the rolling mill, so it wasn't an area where people went to very regularly, after a period of time the grease would deteriorate in the bearing would seize up, and you'd be up for an expensive repair job and a lot of downtime. So that was the concept. So what they realized was the best people to identify these little problems at the earliest possible time would be the operators. So TPM is about training the operators to identify equipment defects at the earliest possible time so that maintenance can fix them. As such, it is a change of thinking for everyone at a site and requires a number of activities to be initiated in the correct sequence and to a required standard. So it's not just rushing out and training the operators to find defects. What we've found is there's a number of things we have to do in the right sequence if we want this to work and be successful. So what are these things we need to do? Well, first of all, it's about improving the performance of the equipment. So we've got OEE, it's a typical measure used in TPM for measure equipment performance, overall equipment effectiveness. So it's about using cross-functional teams to break down barriers and improve existing equipment performance so as to create time to access equipment in normal work time to train the operators. If you want TPM to be successful, you've got to get the operators to be able to train and learn about finding defects, and that means stopping the equipment in normal work time. So you need to improve your performance of your plant before you can start doing that. The next thing is we need to make sure the structure is correct, that we have production area-based teams of about 4 to 8 people with a designated frontline leader, and our rosters are aligned between production and maintenance, so they get regular support from maintenance from the same person so they can learn and build a relationship up. Third thing is we need to make sure the operators know how to operate the equipment properly, that they have the proper base skills, that we have all the centerline settings for the equipment right, and people are operating the plant to an agreed standard, and that the operators can operate their area of responsibility, that they can all operate it, so you have flexibility within your production area-based team. Then we need to initiate production area-based team improvement activities using, we call it work area management, other people call it 5S, so as to establish the discipline and orderliness necessary to support operators taking responsibility for the care of their equipment. If the operators don't have the discipline to, for example, put the brooms back on the shadow board or the tools back where they should be after they've used them, you don't want them going near equipment and start doing things that could have impact on the equipment performance. So we need to establish the discipline before we start. Then we need to have a maintenance capability that can support operators. So we need a support capability that can respond to small problems and issues identified by operators. So we, one, need to free up the time of maintenance people, and secondly, we need to set up a defect management system to complement and work with the work order system. We don't want putting defects into our work order system because they'll just get prioritised into insignificance. We need to have a separate system in place so that we can respond to defects rapidly. Then comes the interesting one about a stable production plan. If we want maintenance and production to work together on regular clean for inspections so they can learn and find all these defects at the earliest possible time, we need to do it in a stable workplace environment. So what we introduce is what we call a stable production plan based on flow logic, and that is basically taking the variability of the production plan out of the factory and putting it into the warehouse. And in doing that, you can have at least a couple of days of a fixed regular schedule of production. Typically what they've found is that, and Ian Glenday has done a lot of work on this in his research, that about 6% of the products that you make, or SKUs, make up about 50% of your volume. So if you can stabilise those 6%, you'll have at least 2 days of, maybe even 3 days of stable production. And then during that time you have your regular clean for inspections that you know are going to happen on a regular basis. Then you get into the regular clean for inspection, so we're training all operators to identify equipment defects or problems at the earliest possible time through their regular clean for inspections, and ideally that should be done on a weekly basis. And then so that we speed up the process, we start changing the equipment so it's easy for operators to find the equipment defects or problems at the earliest possible time, like marking, using visual management techniques to put visuals on the gauges, match marks on nuts and bolts, etc., so we can see the problems. So that's the process of getting TPM to work in an organisation. And the thing to think about also, very important aspect of TPM, it's about introducing what we call inductive approach to complement the common lean deductive approach. Now what we mean by that is that if we look at our standard Pareto chart of losses or wastes, our typical approach, and what every lean textbook talks about, is going out there and using a structured, for example, plan, do, check, act scientific approach to problem solving to look at the problems, identify the big ones and fix them. And that's very important, and we do that initially when we start looking at improving OEE. We use the deductive approach and cross-functional teams. But the other side of it is we need to tackle all the small little things on the Pareto chart. And this is where the focus on prevention at source is so critical. So it's the small little losses waste, recognising that the big losses and waste will also reduce and become easier to solve. So it's about a people development focus, and this is where the regular clean for inspections are so important, where we expose equipment defects, fix the equipment defects, standardise the way so we can find them using checklists, and then do regular monitoring. And that is a very, very important aspect of what TPM brings to the table, as opposed to what a lot of lean thinking is all about. So that's what the TPM journey is all about. So how does that fit in with safety? Well, TPM is about creating a productive workplace that is failure-free. We get rid of all the breakdowns because we find all the defects at the earliest possible time. But also, TPM is focused on, once we get the breakdowns sorted out, we are in a position to really tackle the quality problems, because we know every time there's a breakdown, we're going to have a quality problem. Because when things stop unexpectedly, the product gets damaged or wasted. And the other thing is that ultimately we want to get to zero accidents and instances. And what we've found is that once we get breakdowns sorted out, we can work on quality problems, and once we stop breakdowns and quality problems, it has an impact on accidents. Because most process quality problems occur when the plant is not running perfectly, shuts down unexpectedly, equipment fails, or is restarting. And what the research has shown is that accidents can occur in the course of responding to problems such as equipment failures. We had our annual forum last week in Sydney, a very, very successful event. We had some excellent speakers there, and we had one of our keynote speakers, David Sadler from Rio Tinto, who in one of his achievements was working for the CEO in London, initiated activities to reduce the accident rate across the global Rio group by 45% in 1 year. And he made the comment that when he goes to the Rio sites, they have their big maintenance shutdowns, and they do those very well. He says that they plan them out, everyone knows all the procedures, all the isolations, and very rarely do they have accidents. He said what catches them out is when things go wrong with the plant. And that's where all the accidents, or majority of the accidents, come from. When things go wrong with the plant, people are running around trying to do the right thing, trying to get the plant sorted out, and in doing so often expose themselves into risks or habits that they don't, or situations they're not used to. So what we've found is if we want to get to zero accidents, you've got to get zero breakdowns, and that obviously gives you the benefit of zero quality problems, or gives you the opportunity to get to zero quality problems and also to zero accidents. Now, just getting breakdowns by themselves sorted out won't give you perfect zero accidents, but it will help have a big impact on doing so. So just as a question to the audience, love to have your input, and the question today is simply, have you ever had an accident or near miss associated with a breakdown or problem with your production equipment? Has that ever occurred on your site? As I just gave you that story from Dave Sadler from Rio Tinto. So have you ever had situations where something's gone wrong with the plant and people in their haste to sort the problem out have had an accident or mishap? Now the poll is just progressing, and I think we're getting a fair few answers, and I'd like to welcome everyone. We've got people from all around Australia. We have people from New Zealand. We have attendees from India and Bosnia today, so welcome to everyone. And the answers is, yeah, 80% have that situation. This is why TPM is such an important part of improvement. So what's required to achieve zero accidents? Well, you've probably all seen the safety pyramid developed by Mr. Heinrich back in 1931, where he has the figures of 300, 29 and 1. There are other models to this pyramid around where they may have 4 layers on it and slightly different figures, but this one's probably the most common one. Now, what does this show you? Well, what the research showed that developed this pyramid is that for every 300 near misses, you'll probably find you're having 29 medically treated injuries, and for every 29 medically treated injuries, you'll probably get yourself a lost time injury. Now, when we have a lost time injury, hopefully we don't have very many, or we don't have any at all, but if we do have one, typical process is that we go and investigate. After we fix up the person, we investigate and try to get to the root cause so we can implement and rapidly any corrective actions that will stop that accident from happening again. When we do medically treated injuries, when that occurs, typically we do the same thing. We go out, we do a thorough investigation, and we try to initiate any corrective actions that will stop that accident from happening again. With near misses, yes, if we hear about the near miss, we do exactly the same, but unfortunately, often we don't hear about near misses. And as a consequence, we have to try other strategies. Now, the typical strategies we have is to stop near misses is we try to, one, eliminate all hazards in the workplace, which is very, very good, and we go out and we go and run our hazard audits, safety walks, etc., and really focus on everyone identifying any little hazards to make sure all the guarding's correct, that there's no clutter in the walkways, etc. And that's very, very good. However, we've also found that sometimes people have accidents and we go and talk to them and say, well, what happened? And you get some sort of vague answer like, oh, I don't know, I wasn't thinking, or it just happened. And that's where it becomes back to habits and behaviours, where sometimes people don't have good habits in the workplace that can lead to more accidents. As an example, I just grabbed this photo to show where maybe the habits of these people, even though they're trying to protect themselves from the sun, which is very important, maybe this is not the best practice of doing it. So we do get some funny habits in the workplace, hopefully not like this in your workplace, but we do get some funny habits. So how do we address the habits? Well, first of all, we need to understand what is a habit. And basically a habit is something we do without thinking. And if we want to get technical about it, the psychologists will talk to us about conscious and subconscious brain, and how we have a conscious brain where we think about what we do, and we have a subconscious brain where we do things without thinking. And that's basically our habits. And that can be a very good thing. In sport, in music, having habits where we do things without thinking is very, very important, because the subconscious brain is a lot quicker relative to the conscious brain. A simple example of that would be if you're driving your motor car and you need to stop suddenly, who consciously thinks of taking their foot off the accelerator and putting it on the brake, or do you just naturally do it? And hopefully you just naturally do it because it's a habit, it's in the subconscious, and it's done very quickly. As an alternative, if everyone's had the opportunity to train someone or teach someone to drive a car, and in the early days you ask them to stop or slow down, they tend to take a long time because they're actually thinking about what's required to do it. And that's an example of conscious moving to subconscious. To get habits into our subconscious, again, the industrial psychologists tell us we have to repeat the habit, repeat the action 21 times, and we've got to have at least 7 sleeps in between. So there's a fair bit of work to develop habits, and that leads us on to the question of who should be developing the habits, the safety habits of our workforce. The best example I've seen of that was at Procter & Gamble many years ago up at Wyong, where the area-based production team, each month they would identify a small number, 2 or 3 habits they wanted to reinforce, and each team member would each day go around and reinforce that habit with the other team members. It's called safety behaviour habit development or behaviour development. That works very well when you have a mature area-based team where everyone really respects each other. It falls down very poorly where you have a work group where there isn't that high respect, there isn't that maturity in the team, and you can get situations where you go up to someone and say, hey, look here, Kennedy, you haven't got your sleeves rolled down, you should have your sleeves rolled down when you're doing that task. And Kennedy might turn around and say, well, bugger off, mate, I've been here long enough, I know what I'm doing. And then that person doing the audit probably gets intimidated, and they'll continue to do the audits and they'll tick the boxes, but they won't actually talk to Kennedy anymore because he's a bit of a cranky bugger. And we've seen that occur in workplaces as well. So we really need to get mature teams, and then we can start to get those habits working with our people. The other interesting thing with this is if you look at the statistics, the statistics also hold for TPM. What they've found is for every 300 defects identified, you'll probably find 29 inspectable accelerated deteriorations on your plant. For example, a defect might be a build-up of contamination or muck on a bearing. An inspectable accelerated deterioration might be that the bearing's starting to run hot because the contamination's got into the bearing as it cooled down and heated up from being turned off and turned on, and it started to deteriorate. Hasn't failed yet, but you can inspect it and find that it is not correct. And then finally you get failure, which would be the bearing seizing. And they've found for every 29 inspectable accelerated deteriorations, you get failure. And again, when we have failure or inspected accelerated deteriorations, we do analysis, we do root cause, and we take corrective action. Defects, a lot of our people don't even see them. And we've got to change the habits and behaviours, and we've got to develop people that capability to identify defects as they walk past, almost as a habit. And that means we've got to get them doing it 21 times and 7 sleeps. And that's why we have clean for inspections on a weekly basis, and after 6 months you might start to get an impact on teaching people to identify defects. It was interesting, we did a workshop recently in Sydney at a site, and we asked people to go out and we took them to a section of the plant to look for defects. And the interesting thing is that people found all the housekeeping issues, all the safety issues, very few defects, even though they were in front of them, because people aren't used to finding them. So how does this all work? Just to finish up, this is a case study or a presentation at one of our forums from Uncle Toby's, where they went down this journey of having significant impact on their safety performance. Their lost time injury frequency rate per million man hours started at 14, which at the time was probably typically the Australian average, and they got it down to 0 or 1, and they put it down to, they improved the OEE we talked about. They got their production teams to get a neat and tidy work area through their work area management and 5S activities, and they developed the safety habits and behaviours from operator equipment management, which is our version of autonomous maintenance, through the regular clean for inspections and working as a very good mature team. The other interesting slide I came across, and this was at a conference back in 2007, and from a gentleman from America, Ron Moore, who's written a number of books and is very well respected. And he took this chart from a leading company in America, a very, very large organization, and what it showed was that as the injury rate dropped away, as the OEE improved. So you started getting your OEE going up and injuries dropped away. OEE came down, injuries came back, and then OEE goes back up, injuries dropped away. And they found there was about an 80% correlation between OEE performance and injury frequency rate, which again, I guess confirms a lot of what we're talking about. So the last one is correlation between frustrations in the workplace and safety. Do you ever get frustrated because the equipment does not run perfectly? Go out and talk to your people and ask that question. And you'll find that whether you talk to operators, maintainers, planners, supervisors, frontline leaders, managers, you'll probably get the answer of yes. And if the answer is yes, I think making sure TPM is on the agenda would be very, very important. As we said earlier, most process quality problems occur when the plant is not running perfectly, shuts down unexpectedly, equipment fails, or is restarting. Accidents can occur in the course of responding to problems such as equipment failures. So I guess in summary, there is this correlation of 0 accidents. Well, you need to get 0 breakdowns before you've got any hope of getting 0 quality problems, and you need to get 0 accidents and 0 quality problems if you want to totally eliminate accidents. In other words, take away the unfamiliar events occurring in the plant. So achieving 0 breakdowns leads to 0 quality problems and 0 accidents. Any site safety initiative where production equipment is involved should have TPM as its foundation, has been our learning. So thank you for listening to our webinar. In the How Can We Help, you had connected to this webinar. You can download the paper Total Productive Maintenance and check TPM. You may find helpful. We've talked about membership. It is certainly, we're finding companies getting a lot of value out of becoming a member, and we've got our access to LinkedIn and YouTube. With that, thank you very much for attending, and I'd like to hand over to question time, please.
Thanks very much, Ross. I'm just having a little look now for any raised hands or any questions in the question box. We've got one question here. It says, thanks, Ross. You outlined a lot of activities required to get TPM implemented, however, didn't mention time frame. How long does it typically take for a successful TPM implementation?
No, good question. Thank you. Yeah, I talked about eight points in that graphic slide of starting from OEE improvement right through to doing your regular clean for inspections and then developing the skills of your operators. Our experience is it takes about 3 to 5 years to get TPM really well embedded into an organisation, and typically you cascade it. You start with the equipment or the production areas that are most critical to you, and then gradually cascade it across the site. But it is a very structured step-by-step development process of your people, but it is also extremely rewarding for the company, as in not only getting rid of accidents and allowing you an environment to get rid of accidents, but also to significantly improve performance and significantly reduce costs.
Wonderful. Thank you very much. It doesn't look like we have any more questions, so that will wrap up our webinar today. Thank you all for attending. Please feel free to contact us at any time if you have any further questions, require information, or would just like to have a chat. Our next webinar will be held on the 13th of September with the topic Using TPM to Enhance Quality Performance at Your Site. On behalf of everyone at CTPM, we hope you enjoy the rest of your day. Wishing you all the very best, and we'll see you next time. Bye-bye.